We're here to calibrate the Eagle with an HF sensor using chlorine gas. HF gas is not available in a disposable cylinder, so we actually can use chlorine as a substitute gas. However, in doing so, we have to take note of a conversion factor for chlorine to HF. And if I open the top of the instrument, we can see the sensor here, and in fact there's a label that states that Cl2 chlorine times 1.6 equals HF. There is a little HF designation for the sensor itself. So basically, we're using 5 ppm of chlorine today, and times 1.6 is going to give us 8 ppm. So basically, we want to adjust our display to read 8 ppm when we have the 5 ppm concentration of chlorine applied for approximately 2 minutes. Okay, now we'll go ahead and get started. Okay, first of all, we're going to air adjust the unit. First of all, we're going to press and hold down the air key. Even though it says 0 right now, we want to do this before we do an actual span with gas. The unit is telling me to release the air key, and it has properly zeroed itself to a clean atmosphere. And of course, you want to make sure you're in a clean atmosphere whenever you air adjust or zero out a sensor, as we call it. Okay. Next, we're going to put the Eagle into the calibration mode, and we're going to press and hold. We're going to press and hold down the Shift Down button, and then the Display button, and that brings up the calibration menu. Right now, it's flashing on single calibration, which in fact is what we need to do. We only have one sensor in here, and that is a HF sensor. So we're going to press the power enter button to enter the single calibration mode. And right now we want to bring that cursor down with our down arrow key to HF. And when it's at the HF position, we'll press power enter. And that brings us into the HF calibration. And right now we see 0 flashing. So right now the unit is ready to accept calibration gas. So we'll go ahead and do that. So the next thing we're going to do is attach the regulator, this demand flow regulator, to a chlorine cylinder. And I'm just going to hold the regulator like so and slowly twist the cylinder onto the regulator until we're nice and snug. Okay. Pressure has come up on the gauge, so we know there's a good seat between the two pieces. Now we're going to push this little piece of Teflon tubing into the inlet fitting of the Eagle. So we have a little push fitting here. We want to just simply push firmly on the tubing until we hear and feel it seat firmly. Okay, now we've got a good connection. Now the instrument is pulling chlorine into it, and we can see the display is going up. And we basically want to flow this gas for about 2 minutes or until the reading stabilizes, whichever occurs first. So we've been flowing gas for approximately 15 seconds at this point. So it's climbing up steadily. Usually these sensors react fairly quickly, and then they start slowing down as they start getting near their top of their response. As we can see, it is slowing down, 5.20, 25, 30, still going. Once in a while, we will come across these special toxic sensors. When you do calibrate them, they'll just keep climbing and almost indefinitely. And if that's the case, if you get to 2 minutes with the reading still climbing, we'll go ahead and make the adjustment at the 2-minute mark. So again, the rule is generally flow the gas for 2 minutes. If the reading stabilizes before the 2-minute period, then make your adjustment at that point. But if the reading is still climbing, once 2 minutes has been reached, then go ahead and make the adjustment right then and there at the 2-minute mark. Okay, we've been flowing for about 90 seconds now, and we can see that the instrument is still climbing up a little bit. It has slowed down. And we got about 15 more seconds. No, it's not too far off actually at the moment. Okay, we're coming up on 2 minutes now, so 7.10 ppm. I'm going to press the up button and bring that display up to 8 ppm. Okay, 8 ppm. Let me bring it back down. Sometimes you have to work with it a little bit to get it right on the money. Press power enter. Okay, calibration end. I will push in the little collar sleeve, push that in toward the unit, and then pull the tubing. Better grip on it. Okay, there we go. If you don't push this little collar in, we'll get a good look at that. If you don't push this little collar in toward the unit, you cannot pull the tubing out. So it's important to push this collar in, then pull the tubing out, because otherwise the tubing will remain locked in place. That's an important point. Okay, so going back to the display, we're back to the cursor flashing at HF. At this point, we want to use our down arrow key and take the cursor to the word escape, and then press power enter at that point. And that's going to bring us back to the calibration menu, at which point we move down to normal operation, press power enter, and that brings us back to normal operation in the instrument. The alarms are going off because we still have gas in the flow system, so the reading is coming down steadily. It may take a while for the reading to come down. Right now it's 0.85 and dropping. Once you get below the alarm threshold point, you're able to press the reset silence, and then you're able to silence those alarms. But that will not happen unless you're below the alarm points. So obviously we are, and we were able to silence them. And right now the reading will just continue to drop steadily until it gets to 0. Although you will note that very often when you get close to 0, but not quite, the unit can take several minutes before it finally clears out. So you want to give it plenty of time to clear out. If it hasn't cleared out after about 5 minutes, then go ahead and just press the air button, and that'll readjust everything back to 0 again. Okay, now we're going to bump test the Eagle with an HF sensor using chlorine gas. We've already properly calibrated the Eagle to the chlorine cylinder, and that is because we can use chlorine as a substitute gas that's readily available. You really cannot get HF, hydrogen fluoride, in a disposable calibration cylinder, so chlorine is a very convenient substitute. The sensor, the HF sensor in the Eagle, has a conversion factor of 1.6. So basically that means chlorine times 1.6 equals HF. Since we're using 5 ppm of chlorine, 5 times 1.6 is 8. So that's where we had set our span in the Eagle to read 8 ppm when chlorine was applied at 5 ppm. So again, we're properly calibrated. We're just going to show you how to do a bump test, which is very easy to do and simply involves applying the gas to the unit while the unit is in normal operation. The Eagle does not have a formal bump test mode, so don't worry about going into a special bump test mode to do a bump test. Really, you're just simply applying gas to the unit while it's in normal operation like it is now, and then just observe the readings. If you do this on a daily basis, or at least on a frequent basis, a few times a week, or whatever frequency protocol you want to do, before you apply the gas to the unit, you want to make sure you have the unit in a clean air environment. It's been on for a few minutes, let's say at least 5 minutes, and is warmed up. At this point, we're going to press and hold down the air button, and it'll say demand 0, adjusting 0, hold air key. And for 0 adjusted, release air key. So I'll release that, and again the unit's still reading 0, but at least we know we freshly zeroed the unit in a gas-free atmosphere before we apply gas to it. Okay, right now we've got the regulator attached, this demand flow regulator attached to the cylinder. This demand flow regulator is normally off when it's not connected to a vacuum suction as being applied by a pump. So basically it's off right now, but as soon as I connect it to the Eagle's pump is actually going to open up the valve in the regulator, and the gas will start flowing automatically. So obviously The opposite of that is when you're done bumping or calibrating, just simply pull the tubing away from the eagle and the regulator automatically turns off. Okay, so now we'll attach it. We're going to take this piece of Teflon tubing and just firmly insert it into this push fitting on the eagle and push firmly until you feel it seat. You can also hear it sometimes seat as well. Okay, so now the eagle is climbing, and you want to apply gas for at least a minute, maybe a minute and a half. When we calibrate the unit, we apply the gas for 2 minutes and then make the calibration, or I'm sorry, make the adjustment at the 2-minute mark. But right now we're going to just apply the gas. I've had it going for about 30 seconds now. And we'll see how close it gets to 8 parts per million. So usually you will see the display deflect quite rapidly in the beginning as it climbs up, but as the unit gets closer to its final response, it will start slowing down. Okay, we've been flowing for 1 full minute now, and the unit's at 7.5 ppm out of 8. That's not too bad, really. And there's different things you can do to validate a bump test. That is, see how far it goes, how close. We're at 8 ppm now, so we're not even a minute and a half yet. So I'm going to go ahead and pull the gas off. And again, we want to push in the collar. Oops, I'm sorry. Okay, and then simply pull the tubing out. Okay, so the regulator shut off because I disconnected the tubing. And now we're just going to wait for the reading to start dropping. So again, we achieved the calibration value on our bump test in about a minute and a half, roughly. And then when the reading drops below the alarm points, you will be able to silence them by pressing the reset silence button. Okay. So right now I was able to silence the buzzer, but the LEDs are still flashing. So that means I'm between, when I press that reset button, I am between the low alarm and the high alarm points. Once the reading drops below the low alarm point, I'll be able to press the reset button again, and that will turn off the LEDs. Okay. And the reading will continue to drop towards 0. And it may take a few minutes before it clears out of the flow system. So you may want to conduct bump tests just by looking to see that the alarms are tripped. Some people do that. They just apply the gas long enough to make sure it reaches the alarm points and trips the alarm points. Other people like to see how close it gets to the cal value. It might be a value of plus or minus 30% of the cal value, or 20%, or 15%, something of that nature. Usually 20 to 30% is a good quick value to arrive at, so that you can do your bump tests quickly. You don't want to make the parameter, the plus or minus parameter, too close to the cal value, because otherwise you're kind of defeating the purpose of the bump test. If you're going to get too close to the cal value, you might as well just calibrate the instrument in full at that point. And the reading is still dropping. And we're just about to 0, 0.05. There we are. Now we're at 0. And that concludes the example of bump testing the Eagle.